When we're working on estimating a population proportion from a single sample proportion, there's several things we need to be able to deal with. The values of z for z sub alpha over 2. Recall that z is the number of standard deviations away from the mean. When you have a subscript like that, this means the amount of the area under the curve which is above that z value. So we're talking about finding a z value right here where the amount of the area under the curve but above that z value is alpha over 2. Alpha represents 1 minus your confidence level. Your confidence level should have been determined before you ever start an experiment or a survey or anything, and it's usually 90%, 95%, or 99%, with 95 being the most common. So this, the alpha, or the confidence level rather, represents the amount of area between these z values. This is your confidence level in here. Let's say this was 90%. Well, in this case, it's 80%. We'll go with this problem. So in this case, we're talking about a confidence level of 80%. That means that alpha is 1 minus 80%. Well, that's 100% minus 80%. So it's 1 minus 0.8 or 0.2. But the 0.2 is split between both the tails. So if this is 80%, then the 0.2 is split between these. These are 20% between them. So this means that each of these contain 10%. Your z value for alpha over 2 in this case, because alpha over 2 is 10%, then we need to find the z value that has 90% of the area under the curve below that. We need to find the cutoff actually between 10%, and therefore these two together make up 90%. So if you're looking at a table, you're going to find your z value that goes at a 90% cutoff. However, if we're using StatCrunch, to use StatCrunch for this, we want to go with the stat, the calculator, normal, and we want to find the z value. So we're going to leave the mean at 0 and the standard deviation at 1. We need to find the z value, which is the cutoff for 90%. And that is going to be 1.28. And you'll notice that's the same answer they've got over here. What if we looked at, let's look at a different amount. 92%. For 92%, that means that alpha is 8%, which means alpha over 2 is 4%. So we want to find the z value for 4%, but this, again, is the amount of space above it. Another way to do this is just come over here to our calculator, set this at greater than or equal to 4%, 0.04, remember, and that's going to be 1.75, 2 decimal places, and that's how you do it.